So we've got to get to the similar base. Okay, which means if you have the numbers 4 and 2, I can't raise 4 to a whole number to get to 32. But I can raise 4 to be 2 squared. And I can raise 32 to be 2 to the 5th. That I can do. And then we have 2 to the 4x plus 8 equals 2 to the 5x minus 25. And once I get those similar bases, I can simply set the exponents equal. 4x plus 8 equals 5x minus 25. I like to keep the x's positive. That's just me. Add 25 to both sides. Add 25 to both sides. And I get 33. My next problem, same deal. I'm going to look at the smaller number, 25. Can I raise 25 to anything to get to 125? No, not at least in a whole number nature. But I can make 25 5 squared, and I can make 125 5 cubed. And we're raised to 3x minus 5 on the left, we're raised to 2x plus 7 on the right. When you raise a power to a power, you multiply. And it's 9x minus 15 equals 4x plus 14. Once again, I'm a big fan of keeping the x positive wherever I can. In this case, we get 5x equals 29, and my answer is 29 over 5. Finally, I'm going to treat that 1 over 81 like it's an 81. Okay, whenever you have that number in the denominator, treat it like it's in the numerator initially. There's nothing I can raise 27 to get 81. So I'm going to make 27 3 cubed. Put it over here. To the 3x minus 2. I'm going to make this 81 3 to the 4th. But because it's 1 over 81 instead of 3 to the 4th, I'm simply writing 3 to the negative 4th. And we're writing a power to a power. 3 to the negative 4x minus 16 equals 3 to the 9x minus 6. And then we set the exponents equal. Negative 4x minus 16 equals 9x minus 6. We add 4x to both sides. We add 6 to both sides. On this side is 13x. Negative 6 and 6, negative 16 and 6 is a negative 10. Negative 10 over 13 is my x. Alright, so finding x here. This really comes down to number sense. The 4 raised to the x equals a 64. So a lot of people, I think, a lot of times like to convert it to exponential form. My x equals 3. My base raised to my exponent equals the number here. X to the negative 3 equals 1 over 27. 3 to the negative 3 equals 1 over 27. This one's pretty straightforward, even though it's a fraction here. This is 2/3 to the 4th equals x. If you take the raise an exponent to the 4th, all you're doing is raising the numerator and the denominator to the 4th power. 2 to the 4th is 16. 3 to the 4th is 81. When you have a radical, you have the same number under the radical. basically means your exponent's going to be a fraction. Okay? We got to convert the cube root of x to a fraction, although it should be the cube root of x. Excuse me. 8 to the x, cube root of 8. And then the cube root of 8 is simply 8 to the 1/3. So if I raise 8 to the 1/3, okay, that gives me the cube root of 8. When you see a radical, it means you're going to have a fractional exponent. Now, on this one, I had to change this number, so I'd lay everyone right now. I believe the number 7 on your paper, or number 49 on your paper, is that right? Change this. Okay. So what I'll do is I'm going to do the problem as is, and I'll do the problem what I meant it to be. So x to the 1/2 equals 49. Okay. So basically, we need to know what number, if I take the square root of it, gives you 49. Now with the calculator, it shouldn't be that difficult to do. If you go to your calculator, it's simply just 49 times 49. But in fairness, okay, that's not really what I was looking to give you. What I was looking to give you is this, and this is where I messed it up. The log of x is 7 equals 1/2. That's what I meant to give. Okay, so you will not get a number that high on your test. If you want to write this one down, you can. X to the 1/2 equals 7. Guys, even that's one we really should know. We should be able to translate raising something to the 1/2 to the same thing as taking the square root of it. Okay, so in this case, the answer is x equals 49. And then finally, anytime you raise something to the 0, automatically it's 1. Okay, anytime a log equals a 0, it's automatic that this is 1 right here. Because anything raised to the 0 is 1. Okay, now the big thing here is this. Is there a log on both sides or not? Okay, that's what we're really looking for here. In this case, there's not a log on both sides. So, when I do this problem, it's this raised to this equals this. It's 3 to the 4th power has got to equal x minus 3. 3 to the 4th is 81. I add 3 to both sides and I get 84. And the big difference between the top one and the middle one is this. The middle one, you have a log base 5 in both sides, on both sides of the equal sign. When you have that log on both sides of the equal sign, you're literally just setting these equal. 4x plus 6 equals 2x minus 8. We subtract 2x, we get 2x. We subtract 6, we get negative 14. We divide by 2, we divide by 2, we get x equals negative 7. Okay? Now, the fact that I got x equals negative 7, if I plug that back in, we get negative 22 and negative 22. So therefore, this is a no solution. Remember, you cannot have a negative with your log. So it is important, once you find your answer, to plug your number back in to determine whether you have a negative or not. Okay? That's not an optional thing. The natural log follows the same rules as log. So if you have a natural log on each side, we can literally set these two equal. When you have an x and an x squared, that should be a signal I'm going to have to factor. So we have x squared plus 8x minus 20 equals 0. X plus 10, x minus 2 equals 0. So my answers are negative 10 and 2. Now, I plug negative 10 in, negative 10 squared is 100. 8 times negative 10 is negative 80. 100 negative 80 is 20. 2 squared is 4. 8 times 2 is 16. 4 and 16 is 20. In this case, both answers work. Don't skip steps here. Okay? When you condense, you have to get it down to 1 log. When you expand, you got to get it where every term has its own log. So here, I'm going to deal with the exponents first. The 2 comes up here. The 3 comes here, so it's log base 3, 3y cubed. Minus the 4 comes here, and it's log base 3, z to the 4th. So you deal with your exponents first. Now, I'm going to distribute that exponent. 3 cubed is 27y cubed minus log base 3 z to the 4th. My advice to you here is this. Do not skip steps. Take one step where you deal with the addition sign. And that's going to leave me with 27x squared y cubed minus log base 3 z to the 4th. Take that one step and deal with the addition sign. And then we subtract. That means we're dividing. 27x squared y cubed over z to the 4th. And that's going to be your answer. Next one. Deal with your parentheses first. This becomes 4 log base 2 xy minus 3 log base 2 3 log base 2 2z. Now I deal with my exponents. The 4 comes up here. So log base 2 xy gets raised to the 4th. Minus log base 2 2z gets raised to the 3rd. Log base 2 x to the 4th y to the 4th minus log base 2 8z cubed. We distribute the 3, we distribute the 4. And then I finish with my subtraction sign, which represents x to the 4th y to the 4th divided by 8z cubed. And that's our answer.